Hello, everybody. Christy Giannoni back in week 6 for our MPA 560 Statistical Analysis for Public Administration. This week, I will be going over the program design overview. I have been taking a look at the program called STEP for the City of Redlands. This is a selective traffic enforcement program that was granted to the City of Redlands Police Department by the California Office of Traffic Safety, or OTS. I'm reviewing specifically the grant period for October 1st, 2017 through September 30th, 2018, and the purpose of this program is to reduce the number of persons killed in motor vehicle collisions involving alcohol. And while there are various elements to this grant that they can take a look at utilizing, such as speed control, saturation checkpoints, I'm going to be focusing specifically on DUI checkpoints. These are the variables that I'm taking a look at. The one in the middle, defined by that red circle, is my dependent variable, the number of fatality victims in alcohol-involved vehicle collisions. And then the three outer circles represent independent variables, one, of course, being the program of DUI checkpoints, and additional being age, which would be collected by obtaining the information of the person's age in years as listed on their California state driver's license or any other state driver's license that they would have, as well as a third confounding variable of bars in the area. So in taking a look at the research question of do DUI checkpoints reduce the number of alcohol-involved motor vehicle fatalities in the City of Redlands, the design evaluation would be a quantitative study, and this would be aimed at analyzing the relationship between the dependent variable of the problem and the independent variable of the program. This would be quasi-experimental in nature because it aims to establish a cause and effect relationship between that dependent variable and the independent variables. The design proposal would be design framework number 4 as defined in our textbook. The real world evaluation by Bamberger and Mabry. This can be found on page 203 where it lists the various design frameworks. And this design framework is illustrated by a pre-test and post-test combined with a post-test of a comparison group. So the pre-test would be the data that we would collect before the program of DUI checkpoints was implemented, and then post-test would be the data that we collected after the implementation of the DUI checkpoints. And then we would take that information and we would do a post-test comparison of a different city or agency of a comparable size. And we would only do this in the post-test component because the other city would not be doing a program like STEP. The method to collect the data would be through the OTS crash ranking results. This is a website that we're able to obtain this data, and that crash data comes from Statewide Traffic Record System, or SWTRS for short, and local government agency law enforcement are required to enter this information via a form. It's a California Highway Patrol form. It collects all of the data information from a crash, and then the data collection would also involve, again, obtaining that age from a California's driver's license, and we would be able to obtain the number of bars in the area from the economic information from the City of Redlands. For the purpose of this data design, there will not be any sampling. We will be using 100% of all of the data, including the number of fatalities and the vehicle collisions that involved alcohol. So thank you for listening to my presentation. Best of luck to all of you as we finish off these last few weeks, and I hope you have a blessed weekend.